Hello and welcome to Verx Gaming. My name is Professor Robert and today we are going to be doing multiplication and division in binary just to show you guys, you fellas, how it works. Now, if you haven't seen my previous 3 videos, it explains what binary is, how to convert between the two, and how to add and subtract in binary. So, I'm going to put that link in the top right if you haven't seen it yet, and if you haven't seen it, go watch them, because I'm not going to explain that in this video, and if you don't know that, you're going to be confused as crud. So, let's start out. Again, I'm going to show you base 10 multiplication, and then you know what? No, I'll do this. I was going to use different numbers because this is going to be a big number, but it's okay. It's going to be a lot of zeros, so it's simple enough. Alright, so now, let's write this. So this is our base 10. 9 times 2 is 18. So now we're going to write that in binary. So let's write our 9. We have 1 in the 8's place, none in the 4's place, none in the 2's place, 1 in the 1's place, 2, 1 in the 2's place, none in the 1's place. Now we're going to multiply. And now this is just like, it's the same procedure as multiplying in base 10. So we're going to multiply everything by this digit first. That was really bad, square. And then we're going to multiply everything by this digit second, and the stuff that we multiply by this digit we're going to start in this place. We're going to start in the 2's place. When we multiply by this digit, it's in the 1's place, so we're going to start in the 1's place, and then we add the remainder together. So let's show you what I'm talking about. 0 times everything is 0, so we're just going to go ahead across the board and write that. Now, time to multiply by our 2's place. So again, 1 times 1 is 1, and now you start in the 2's place. Remember that. It's just like when you multiply in base 10, same procedure. You multiply across again, 0, 0. Make sure you keep it aligned up and down. Don't start writing your 0 really big because that'll mess you up. And then 1 times 1 is 1. Let's add this up. Again, start right to left. I always like going left to right. And that goose with you if you ever have to carry. So there we go. This is our number. And we already know it's 18. We know that these two are congruent. But I'll prove it to you. Just because why not? We have no 1s. We have 1, 2. Now I'm writing this in base 10, so don't get confused. Okay, so we have no 1s, 1, 2, no 4s, no 8s, and 1 16. And that is equal to 18. So these two numbers are congruent. This symbol means the same thing as this symbol. Just remember that. Alright, so I've showed you some multiplication. Try a few problems on your own. If you need help, throw it in the comments. I'll help you out, don't worry. But let's move on to division. Now division, let's do a nice division. 8 divided by 2. So you know how division works. How many 2's can go into 8? 4. Yes. So the answer is 4. Very similar. We're going to use the same numbers here. This symbol is the same as having 2. This symbol is the same as having 8. Now let's do our division. How many 2's can fit in 1? None. How many 2's can fit in 2? Well, 1 2 can fit in 2. And now, so now we multiply that 1 by 2. To tell you the truth, I'm not exactly sure how they speak in binary. I've never thought that through. So I don't know whether to call this 2 or 1 0 or 10, or I don't know what you call that. So I'm just going to call it what the base 10 calls it. So I'm going to call it 2. Alright, so 2 minus 2 is 0. Drop down your 0. Well, there's absolutely no 2's in 0. Drop down this 0. Absolutely no 2's in 0. Oh, you know what? I skipped a step. Don't skip steps. 0 multiplied by that gives you 0. 0 multiplied by 2, sorry. 0 plus 0 is 0. Drop down to 0. How many zeros? How many 2's, sorry, are in 0? There's 0 2's in 0. There we go. Multiply 0 by 2. Let's figure out what our remainder is. 0. Just realized I goofed this symbol up. Sorry, people. That's a subtraction sign. Alright, so this was a nice problem. We have no remainder. Let me prove that this is the same. Nothing in the 1's, nothing in the 2's, 1 in the 4. There we go. So, as you see, there's just 2 different ways of doing your division. It's that simple. Alright, now I'm going to do one with a remainder. Now this might be a little confusing. It confused me at first. I was thinking, how the heck are you going to do this? But it's not that hard. So, how many 2's are in 9? Well, we know there's 4. 4 times 2 is 8. Subtract. Okay, 9 minus 8 is 1. Now wait. Whoops. We're not going to be doing decimal points. We're going to forget that. Let's do fractions. So we're going to do the remainder. Now, it's been a while since elementary school. I almost forgot how to do a remainder. But the way you write your remainder is 4 1/2. So all you do is you take this number, throw it on top, take this number, whoop, throw it on bottom, and ta-da! You can do it in decimals as well, but it's a little more confusing in decimals. I'll have that in the next video. Hopefully. Maybe not. I'm not the best doing it in decimals, so we'll see. But anyways, now let's do this in binary. There's our 2. There's our 9. Now we're going to do our math. So how many 2's are in 1? There's none. How many 2's are in 2? There's 1. Zero, drop down to 0. I'm just going to speed through this because I'm a quick scoper. And when you're a quick scoper, you don't need to do anything people tell you. Alright, so here's how it works. We get to this last section. Remember, this number right here is 1. Remember, how many 2's go into 1? None. So we put our 0. 0 multiplied by 2. So our 2 there, 1 minus 0 is 1. So now here's our remainder. Now just like we wrote the remainder over here, remember it's the same steps. You do everything the same, just with different symbols. We're going to write our base number, the one we actually got, so our 4, and then we're going to write our remainder, 1, over what we divided by, 2. So now here you have, this is congruent to 4 and 1 over 2, 4 1/2. So there's how to divide and get your remainders nice in binary. And now, if you can think of this, if you have some ginormous number, so let's say you have 695 divided by 22, that's going to end up being messy. Now, switching it to binary, you'll have a lot of writing. But the trade-off is there's not much thinking. It's always how many 2's or how many 4. It's very simple. Well, how many 22's would go into this, and all that you have is a few 1's and 0's, so it's really easy to compare, and that's what's nice about binary. So if you're struggling with something in base 10, maybe give it a try in binary. If you guys need any help with this concept, shoot me a message in the comments or DM me on Twitter. Thank you so much for watching. I'm tired. I'm going to bed. Have a good night.